Vinny. So thank you so much for coming out. This morning's such a great lineup. I would rather be in all the other talks other than mine. I mean, that's a normal state of affairs, but there is a really great lineup here. So do make sure you check out the videos of the other presenters for the sessions that you couldn't see. So my name is Sam Newman. I'm here to talk about microservices. Some of you may have read my book on building microservices, which contained nothing about serverless because we didn't really use the word back then very widely. So now I've got to do a second edition. So thank you, progress. I also, as Penny mentioned, I work for my own company now. I do training, advising, and consultancy work in the area of cloud, microservices, and continuous delivery. But you can find out more information at my website as well, which is where I'll also have the slides for this presentation. So this year, the last couple of years have been fairly momentous years for me. I don't mean in terms of politics. I mean quite selfishly for me. I mean, I created a company with my own name, which I think just highlights the inherent narcissism and ego that I have. So we're a rather self-obsessed generation, so I figured I should be getting in on that gravy train of being also self-obsessed. And I think a lot of this came about because I'm now starting to feel very, very old. I turned 40 fairly recently. I know you wouldn't tell to look at me, but I am now 41. I was explaining to my son the other day that the first programming language I ever used was written in 1977. That was back in an era when you used a programming language, they put the year it was written in right there in the name, and so you really knew how old the technology was you were using. I kind of miss those days. So anyway, I also remember when the internet came on a floppy disk. I do remember the 5 1/4. I even remember the 8-inch floppy disks, just to really date me. We used those at school. And I remember when the internet used to arrive often on a magazine, on the front of a magazine, and you could connect it, and the thrill I got when I got my first 14.4K modem. And I still call Facebook the Facebook because that's its name. Again, progress isn't always good. I don't use it because I don't understand it. Equally, I do not understand Snapchat. I don't understand what's going on with Snapchat. I watch people sort of making grinning faces and take photographs. I don't understand how that business is worth billions and billions of dollars. But then again, I've come out of 2 really failed startups, so you really shouldn't talk to me whatsoever about those sorts of things. I'm not a complete and utter Luddite, though. I have been using cloud services for a very long time. I sort of by accident ended up helping create the first ever training courses for Amazon many years ago, 10 years ago now. Sort of stumbled into it very early days. And so I've always considered myself to be a person who actually, when it does come to new technology, can sort of get my head around things fairly easily. I like trying to distill down the essence of the thing and try and understand what actually makes it important. I was a consultant for many years, but an odd kind of consultant because I liked spending my time avoiding talking about hype and buzzwords, which again you'll think is doubly ironic for a person who wrote the book on microservices. But nonetheless, you know, we are people of cognitive dissonance, all of us. But nonetheless, serverless has absolutely left me a bit confused. It's taken me about a while to sort of get myself and dig myself out of that confusion. And that confusion starts with the name. Like any name, you start, well, what is that name about? You start trying to dissect it and think, well, what the hell is this serverless thing? Now, obviously, as somebody who is independent and is basically trading on my former glory, I'm always worried about some new hype or buzzword about to destroy my business. You see, right now in the Gartner hype cycle, my own personal subject matter area of expertise, microservices, is clearly running high. And as we all know, any consultant can turn a Gartner hype cycle into profit. But I'm concerned here about serverless coming up on the left and figure I better find out what the hell's going on, just in case I need to shift my allegiances from one bandwagon to the other. You can surf 2 bandwagons at once. Don't try and do a third. That's all I'm saying. So when you start digging into serverless, of course, the first thing you start seeing is the the sort of cynics saying, well, serverless, there's no such thing. You know, there is no cloud. It's just other people's computers. And this is sort of where I sort of started from, as somebody who's a half an ops person. I fell into operations accidentally. I was on a project, and I was the only person that knew Unix, and therefore I ended up doing all of the sysadmin work. That's how these things normally happen. So I know there are computers there. I've had to look after them really badly, but I've had to look after them in the past. So I sort of shared this cynical view. And I was sort of interested in sort of the origin of the word as well, because often when you look back to the origin of the word, there's some truth or there's some reason or rationale behind it, then subsequently gets lost. The same thing, I think, happens with microservices, it happens with DevOps, it happens with Agile. If you go back to the origin of these things, you can often understand, well, what was the idea behind it? And serverless, just as with microservices, was nothing more than a banner term slapped on some things that were already happening. I think the first citation I can find for the word serverless comes back to this article by Ken Fromm on RW Labs. And it's an interesting article. This is back in 2012. And Ken was reflecting on the different cloud technologies out there and saying, you know, this is sort of the description of this. And I'm sure the word was around before this. This is the earliest citation I can find. But the phrase serverless doesn't mean we no longer have servers. It just means that developers no longer have to worry about the underlying computers. We're not worried necessarily about managing around physical capacities or units. There's something here about abstraction. It's not saying there are no computers, it's just that those are abstracted from us. We'll come back to that idea of abstraction later on. Now, the reason I want to pull back to this reference, this is 2012, is because one of the first signs of confusion I saw was a conflation of terms. When people say serverless, a lot of people say, well, serverless is just functions, which is kind of incorrect. That's sort of like saying that Agile is just continuous integration, or Agile is just stories. Function as a service is maybe part of what we call serverless. It might be a product which is classified in the term serverless, but it's definitely not what serverless is and the entirety of it. And we can see this very simply by looking at when Lambda was launched, which was in 2014, 2 years after the term was first created. So Lambda might be one of the examples you know best as a cloud product that gives you serverless capabilities, but it's far from the first thing that was being talked about as being a serverless product. There is also this other issue that comes on that certainly people like me, operations people, think, well, I've got to manage the computers. But we come back to that definition from Ken, which is the developers no longer have to worry about the underlying resources. As developers, we work with some platform that we find fantastic and amazing. It's great, look, there's no detail here. But of course, underneath it all, there's an awful lot of heavy lifting going on, which confuses operations people, especially when you talk to them in traditional organizations. You start talking about serverless, and it's like, where are my jobs going? The key thing here is not only are these somebody else that are looking after these computers, they're often people in a separate company that we don't even have to worry about. But like all abstractions, serverless is very much about, you know, the eye of the beholder. It's all great from my point of view, but I know somebody somewhere is having a really, really bad time. Now, I started wanting, okay, so we've got serverless, so I'm getting closer. So serverless is about abstractions. I'm being hidden to an extent from the computers. But hiding me from computers, there's lots of software that hides me from a computer. There has to be a more accurate definition or encapsulation of what serverless is about that would help me understand why is it useful, what products are and aren't serverless. Does that trade into how I think about using technology? Mike Roberts, who's an old colleague of mine, wrote up a big piece on Martin Fowler's website on serverless architectures. And so he was trying to explore this space, look at different ways of using serverless technology. And this is really a great introductory article if you want to take a look at. He's also, with his colleague John Chapin, done a short book for O'Reilly, which you can download for free, which goes through this in a bit more detail. Mike's come up with these definitions of what serverless is, his sort of 5-point definition, which I think starts to get a little bit closer. So Mike's 5 definitions of serverless is that we don't manage server hosts or server processes. Again, this is from the point of view of the user, the developer using these server systems. We self-auto-scale and auto-provision based on load. So we don't have to think about those things. They'll just scale up or scale down as we need. The cost is based on precise usage. This is a real pay-as-you-go model. So you're not paying for a process to be running 24/7 if you only use it for a few minutes a day. You're paying, hopefully, for the few minutes per day. And the performance capabilities are defined in terms other than host size or count. This can often be bewildering to us, actually, as developers. If you start using, especially some of the database options, things like Cosmos, where you start talking about allocation units, it gets incredibly confusing as to what the hell's going on, in fact, when sometimes it's quite nice just to deal with a good, old-fashioned, I want a big machine. And then finally, we've got implicit high availability, that the system itself is just going to handle resiliency for us. We're going to come back to that idea of resiliency because I'm not sure it's entirely true. Now, I think Mike's getting a lot closer here with the definitions. Although it's kind of interesting whenever you make a sort of explicit definition like this, it starts becoming fun to see what things fit. What exactly things fit into this definition of serverless. So obviously, we've got the function as a service type offerings from people like Google, Microsoft, and Amazon. I think Amazon Lambda gets a lot of the attention. I actually think Microsoft Azure's cloud functions are actually better executed products, personally. So, props to Microsoft for that one. But we have to look as well at the various different backends of the service that we have. Things like Cosmos, Dynamo. The databases actually get a lot more confused. We sort of assume that all these products are going to be complete turnkey, that they're a simple, just turn it turn it on and off you go. It turns out that when you start getting into the database plane, that things get a lot more complicated than you might think. With a function, you tend to talk about how much memory you're going to give the function. That's it. But when you start looking in the different database options from the vendors, you start realizing, oh, this idea that there's no operations work and this stuff just magically works out how to scale turns out to be a little bit far from the truth. Now, it's interesting for me because I still hold up the gold standard of a developer experience for deploying and managing applications as HEROKU. I still think it's by far the best execution of a platform as a service. And it's no surprise why multiple companies have basically copied that developer experience. You're looking at organizations like Dias, and you're looking at the sort of rewrite of the Cloud Foundry interface to mimic HEROKU-like deployment. And that's for good reason. It was excellently executed, and developers love working with HEROKU. Kind of interesting thing here is that doesn't match Mike's definition of serverless. It's because we're still managing containers. You talk about a certain number of dynamos. Our costs are based on the number of dynamos we're running, not necessarily on whether those dynamos are being used or not. We certainly don't get implicit high availability with those mechanisms either. It's still fantastic. So herein is the first lesson. You can use fantastic stuff if it's not serverless. Don't let that worry you. The kids might bully you in the playground, but you'll still be a happier developer. Turns out there are other things that sort of fit into Mike's definition of serverless when you get down to it. Let's start with Salesforce's Force.com platform. There you go. I can deploy my Apex functions, which is a horrific thing, but I can use effectively Salesforce like a platform as a service. I'm not managing containers. Things are just run and scaled on my behalf. It doesn't really fit what I think of as serverless, though. There's something a bit missing there for me. You could also argue things like Fastly or Cloudflare are serverless platforms. I'm being charged based on my bandwidth use. Cloudflare, for example, will even allow you to execute code on the edge now. That is a serverless product. That is a serverless cloud feature. It's not a function as a service platform, but it's a serverless platform. It's highly available. It scales up or down without me need to be involved. I'm charged based on what I use. I think some of the earliest products from Amazon actually fall under this bucket of serverless. Amazon's S3, which was probably, I think, the second or third product they released, or their SQS service. SQS was the first ever product released by AWS in 2006, which is a very, very simple queue. I'm charged based on the amount of items I put into or out of that queue. That is a serverless offering. We've had that with us since 2006. This is just the story, really, when you get down to it, of abstractions. We have a history of creating higher and higher order abstractions. We think about the cloud journey. We started off with infrastructure as a service, virtualized products, virtualized primitives, sitting on top of operational physical equivalents, storage, compute, networking. And then we realized that actually working even with these great virtualized low-level primitives was useful, but we wanted and we urged for higher order things. And so now you're looking at things like maybe container orchestration as a service, things like EKS, for example, or the various different Kubernetes platforms. You could argue that Cloud Foundry to an extent, but certainly the platforms that allow you to manage and orchestrate containers is a higher order abstraction on top of these underlying virtual abstractions. And then, of course, we always had the glory. We always thought that platform as a service was where it was going to be. HEROKU was a very early shining light, and we thought, this is fantastic. Clearly, everybody is going to execute along these lines. And, 5, 6, 7 years on, we're still sort of waiting for this. In a way, when I think about the different products that fit under the banner of serverless, What I'm almost seeing is like in the same way that infrastructure as a service had these virtualized primitives of storage, network, and compute, under the serverless banner, we have a whole load of platform primitives. We have things like messaging, databases, function execution that all sort of sit under this sort of banner up here. And the serverless stuff for me is really the primitives, is the low-level primitives we always wanted underneath the big platforms as a service. The issue always was with the early platform as a service executions, it was sort of a take it or leave it. You had your all in or you're all out. And now we can kind of mix and match these building blocks. Now, of course, you end up, you've also got a lot of confusion in the space, right? Kubernetes is wandering around, where am I in all this thing? And I'm going up stack, and Istio is confusing all this. And you try explaining what you do to people, especially you talk to non-tech execs, and take them through a diagram like this, and you become overwhelmed with acronyms, and it all becomes quite confusing, and you end up feeling like a little bit of a, it gets really confusing sometimes, and you end up feeling like a little bit of an ass. Now, it took, even Kelsey Hightower, who is an amazing campaigner for Kubernetes, which I think which increasingly will become an implementation detail for most of us. He gets it, right? He was like, I love this because I saw this on Twitter, him coming to terms with what serverless was and then coming out with a really nice distinction of what, for him, makes serverless so important. Serverless is about, I don't have to worry about a lot of detail. I'm now just going to let these things get sorted out for me. I'm going to focus on building my product. Right? And this is somebody that is championing Kubernetes, which is all about implementation detail, I think you could argue. We probably increasingly will be hidden from us underneath, I suspect, more serverless-type offerings. I do come back, though, to that Ken From definition. The phrase serverless doesn't mean that servers are no longer involved. It simply means that developers no longer have to think that much about them. This is freeing us up. We don't have to worry. I think there's some lies we tell each other. I mean, we don't have to worry. I think that what it means is we don't have to worry as much. It turns out we worry about a lot less, but the things we worry about are different. For me, it feels like when I moved from being a really bad C programmer to being a mediocre Java programmer, part of the reason that happened was that a whole chunk of my brain when I was a C programmer was worrying about memory management. And it turns out I'm really bad at memory management. I would leak memory all over the place. When I moved to Java, I had more of my brain power to focus on other things because Java did the memory management for me. And this is what happens, right? We build higher order abstractions. This tweet recently, I think, really also summed up another element of serverless that I think gets overlooked, and to an extent is a continuation of the journey that we've had when we've moved to the public cloud. Functions as a programming model, like a subset of serverless. But serverless itself is, as much as anything, a different change in billing. It's a billing model. I don't think it's a new billing model, though, right? I mean, pay-as-you-go has been a challenging thing for organizations as they move to the cloud. For those of us who are developers, this idea that we only pay for what we use has been really attractive. I like the idea that if as an architect I come up with a stupid design, I see the impact in my bottom dollar the next day because I've spun up way more machines than I need, and I get to address that and change that. Whereas before, I would come up with a stupid design. I would then spend 3 months going through a procurement cycle to buy too many machines. I would then have too many machines in my physical infrastructure for like the next 3 years. And that mistake would be looking at me for years and years to come, and there's very little I can do about it. But it's okay, because normally most of us left by that point, and we could get someone else to get the blame for it. What I liked as an architect when I first moved to the cloud, that feedback cycle. I could make a decision, I could see what happens, I could understand the cost impact of that, and it becomes like a little bit of a game, It's fun when you say to teams, right, as a challenge, let's see if we can reduce how much we spend on the cloud. Right? That's fantastic. The serverless, in a way, is just a continuation of that idea. It's giving developers primitives to build applications, and those primitives allow us to have this sort of pay-as-you-go mentality. This is a continuation of the original drive behind the creation of Amazon's internal services to reduce this amount of undifferentiated heavy lifting. Those Amazon teams that were spending all of their time racking up boxes and connecting cables, realizing, well, actually, we're spending all of our time racking up boxes and connecting cables, and we should be shipping software. So how do we reduce those things that don't make us special? my ability to deploy a function shouldn't make me special. My ability to write a function should make me special. And again, this is just an ongoing journey that we're on. So Brian Marek said to me years ago that developers turn caffeine into abstractions. It's almost what we're put on this earth to do. We do it naturally. We like doing it. We fetishize overdoing it. Every single new framework that gets released, every single library that gets released is this a continuation of this. We don't, we started off on machine code, and then along came assembly code, and all the machine code people said that the assembly code people weren't proper programmers, and then the assembly code programmers showed that, yes, we are. Look, we can build entire operating systems in assembly code. And then along came application code and programming languages like, C and Fortran. And all the assembly code people said, you're not a real programmer. And we just keep creating higher and higher order abstractions and waiting for the people from the previous generation to die or leave the industry. And which is great, because then we get to recreate all of their mistakes in our new level of abstraction. So nonetheless, there are still some questions that come around serverless, and they come up quite a lot, so I thought it might be nice to explore some of them. One of the first ones that comes up is this idea of resiliency, and this idea that these platforms are inherently highly available. And that's sort of true-ish. So many years ago, I was working for a company pricing something called collateralized debt obligations. I won't explain what they are, but if you want to watch the film The Big Short about the global financial crisis, you'll get some inkling as to how I sort of helped it along by accident. We were carrying out these calculations on a big grid of sort of pricing nodes. And so the idea was a request would come in saying, do this calculation, and we'll try and do those calculations faster than anybody else in the City of London. That was basically our job. It turns out that just made us lose money faster, but we found that out years later, so it was fine. Now, we were thinking, this is great. OK, we want to go faster and faster. Well, how do we go faster? Well, we've got to add more machines. So we had all these upstream services that we were extracting data from to do our calculations, getting information about different risk levels and market data, sort of invent. We even had data on the weather patterns, believe it or not, coming into our system. The number of kidnappings in Colombia was one of the inputs to some of these financial products. You do not want to know why. And then, we'd put all these calculations into a database, and the world was great, and we felt this is fantastic stuff. And so, one day we thought, well, let's go, how do we go faster? And a friend of ours in the operations team said, Sam, right, we've got a data center sitting there idle. There's basically a whole disaster recovery zone that's turned on all the time that's got to be ready to be used for trading, but it's empty right now. We can just run all the workers for your big pricing cluster on these idle machines. We thought it sounds like a fantastic lunchtime activity. And so we went from about 20 machines to having about 200 machines over basically in the space of 2 hours. It was fantastic. Like, it's completely elastic scaling grid that we just wrapped it all up. And it was great. So this scaled out beautifully. And then some really interesting things started to happen that we couldn't quite explain at the time. What's going on? We seem to be getting a lot of errors. It turned out what had happened is we had scaled up our pricing grid and promptly blown up every single thing that wasn't actually in our pricing grid. And these sorts of things were like, oh, this is mismatched capacity problem, right? And so, we have mismatched capacity problems all the time, and we have mechanisms to deal with these sorts of things. You think about something like a classic application that's talking to a database. We have a connection pool that we use to constrain how many requests can go through to a database at once. This is one of the ways in which we balance the load on a database. You restrict the number of connections that can come in, and hopefully, if those connections have fairly even load, which isn't always the case, of course, we can hopefully make sure the database remains up, and we don't sort of bombard it with too many requests. So as requests come in, there's a certain number of workers, and that becomes a throttling mechanism, right? So we throttle the load, and we can even allow those things to time out if the database underneath us is acting slow, is not responding correctly, and we get rid of that traffic. And so I started thinking about this because I thought, well, hang on a minute. Connection pools are a throttling mechanism to defend other services or other dependent subsystems from being overloaded. I remember I blew up everything that wasn't in this elastic pricing grid because we had no throttling mechanism. Is this a problem for the serverless platforms? And I started thinking, well, if we think about, say, a functional service platform like Cloud Functions or Lambda, Now, what happens is we have these functions running, and as the load comes in, as a request comes in, you launch an instance of that function to handle that request. It's one of the nice things about the programming model. Now, as those requests come in, if I'm talking to a traditional database, that's just going to relate one-to-one to more load coming into the database. And there's no throttling mechanism here, because a connection pool requires shared state across function invocations, which with functions you don't have, because when that request is finished, that function goes away. So you have no throttling state. And I was thinking, is this a theoretical problem? Am I worried about, OK, nuking the database in this way because I've lost the ability to throttle connections via cross-request state? The answer, of course, here is that people, and certainly proponents and vendors, will say, well, the way you solve that, Sam, is you don't use a traditional database that is constrained. You have your functions talk to sort of, cloud-based databases, or serverless-based databases like Cosmos or Dynamo that are going to dynamically scale as that load increases. And then my answer to this has always been, well, that's great, but it sort of implies I'm all in on serverless. So I've got to avoid this mismatched capacity problem. All of the things on that critical path have to be able to scale elastically. And the issue is, I work with most of the clients I work with already have software. It's a surprise, right? And if you want them to embrace serverless products, you can't say rewrite everything over to these new products. You want to give them a path to migrate piecemeal over to this new product, these platforms. And therefore, most of the people I was chatting to that are interested in making use of things like cloud functions needed some sort of migration path, meaning they had sort of a hybrid app status, where they wanted to mix some of their products being serverless and some of the features they're using being implemented using serverless technology, and some of it being more traditional. Now, at this point, I was starting to worry. I'm sort of tilting at theoretical windmills until I saw a really interesting talk by Steve Faulkner at Bustle. And so Bustle are often cited as sort of being one of the great poster children for being all serverless. So Bustle, if you don't know, are a fairly new media company in the US. They run about 65 million uniques per month. So they've got decent load. In fact, they're not all serverless. But I saw this interesting talk from Steve talking about the issues they'd had with exactly this problem. So their back-end data tier is all Redis nodes. We can talk separately about the rationale of using Redis as a database. But they had exactly this problem. They were finding that their Redis instances were being completely and utterly swamped by function invocations. And that was really interesting to me. The really puzzling thing in that situation was the sheer number of requests that they were seeing. Their Redis nodes were hitting the 10,000 connection limit. But at the time, you could only have 1,000 function invocations at any one point in time on Lambda. So these requests were coming in, the functions were being spun up, but those connections weren't actually dying when the functions went away. And so you had these Redis nodes that had over 10,000 inbound connections, and the whole system fell apart. They actually had to do things at the Redis level itself, down at the network level, to expire those sort of connections that were being left behind by the function invocations. You're sort of having to deal with the implementation detail of the underlying serverless platform to avoid those problems. So if you find that, if you search for Steve Faulkner's talk on Bustle, he talks all about these issues that they had. We also have other throttling mechanisms we use, like the circuit breaker. A circuit breaker, again, is a mechanism to allow us to more gracefully handle downstream failure. I'm talking to some downstream service, like the risk service that we had in our pricing example, and if that risk, as the load comes in, all of the requests go through that connection pool and also go through this circuit breaker. If my risk service has an issue, it's not behaving correctly, I can open that circuit breaker state and allow my connections to basically be expired. So I move to failing fast, which can then also lead to load shedding. And load shedding is an important way of relieving back pressure on the system and keeping systems running. But again, circuit breakers, things that we assume we're going to have in a microservice environment, again, rely on maintaining per-client state across requests. Where is per-client state in a serverless environment? Now, my theoretical idea here is that we basically need some sort of magical throttling and load shedding middleware. Something that can give us that cross-state view of our resources that are outside of our function invocation. Something that gives us the ability to do things like circuit breakers and connection pooling that aren't necessary for hybrid applications. Now, I think theoretically, this is what we should be able to use a service mesh for. I haven't yet seen anyone do it, which is the interesting thing. And I have asked some of the vendors. They say, well, theoretically, you could do this. I am wondering how long it's going to be, in fact, before the cloud vendors themselves start providing their own, effectively, service meshes for this exact use case. Because I'm far from the only person seeing these types of issues. Of course, there is still an issue, a potential problem. I might be tilting at imaginary windmills, worrying about my massively, massively scalable application. But of course, one of the promises of this technology is you do not have to worry about high availability. But there's a big difference between high availability of a specific product from a vendor and high availability of your actual system and your solution. And that requires a much more holistic view. Another issue that got cited very early on, certainly around function as a service, was around security. And part of the issue was that first, when Lambda first got launched, is that people very, very quickly busted outside of the function and were able to run command prompts inside the function. And you could see very easily that under the hood, it was all just a container, right? And so under the hood, function invocations are being done inside a container runtime. That's obviously, when you think about it from an operational point of view, it makes perfect sense. Containers spin up very, very fast. They have quite a good quick response time, which is, of course, what we want for function invocations. They're not launching a virtual machine every time you launch one of your Hello World functions, because beyond the fact it would be ruinously expensive, it would also be horribly slow. So obviously, there's some sort of container technology. And the issue, of course, here is that there's this ongoing mantra, containers are great for isolation at some level, but there is this issue about having untrusted code all running on the same container engine, because the levels of isolation that we get from containerization are better than no containers, but they're not as good as virtual machine isolation. And so you start worrying about this multi-tenancy problem. If I'm running my code in a container on the same machine as somebody else's container, is there an issue there? Because we don't like this situation when we're running our own container orchestration platforms. Now, I actually think the problem isn't as bad as it's made out. I think I do have issues with running untrusted code on containers. I think we can talk about the public Docker Hub for a couple of hours if you want to, but that's a different story. Because we have some issues here. Because what we're really talking about here is, well, here's my function, and I'm worried that some other malicious function on the same runtime is going to break out of its sandbox and get hold of my processing, access my data. Now, firstly, it's very hard to see how this would be a targeted attack. Because how are they going to launch enough functions to guarantee that their function is on the same machine where my function is going to be executed? That's an almost impossible problem to solve from the outside. Because again, you are limited about how many of these function invocations you can make. And of course, if my function isn't running, it's sort of not there-ish. And also, we're running in a sandbox. You tend to actually be running inside a runtime. Now, I will say kinda. If your function's not running, it's not there. We know that's not actually true. So firstly, when languages like, when support for things like Java and C# came out for functions, we had this cold start problem. You'd hit the first function invocation, and it'd take a while for that function to spin up. And that could add a delay. And so people were doing all these techniques to keep those functions warmed up so they'd be able to serve their traffic quickly. What's now happened is that the cloud providers have kept those functions running on your behalf. Certainly, for Lambda and on Azure, you can assume that your function isn't really going to, the runtime isn't going to stop running for about an hour. Now, you can't share state between them, but the underlying runtime is still there, so it's not quite the same thing. This has also got a lot better on things like Azure, because Azure, you have the option of running actually completely isolated containers within, so completely isolated kernels, which sort of blurs the line between virtual machines and containerization. So if you look at things like vSphere containers, I want to say, is the way you get isolated containers, isolated kernels within a container, whereas traditional Linux containers all share the same kernel, which is the problem, or at least the challenge with improving that isolation. One of the last sort of big issues that comes up around any of the serverless offerings is this question of lock-in. And I've had a chat with a couple of clients recently who love the idea of what things like backend as a service or function as a service can provide, but their concern is, well, we're going to be stuck. And this is always the issue when you buy into an abstraction, it's how portable is this abstraction? And if you look at the serverless products, all of the serverless products, or the majority of them, are tied to a specific vendor in a way that lower-level abstractions aren't necessarily. Although a function is sort of portable, all of the elaborate sort of management around that function isn't portable. And if you've ever tried using and setting up your own lambda function without the help of a framework, you'll realize what a giant train wreck that is. So trying to port that over is quite a pain. And so there is this idea of, OK, well, I'm going to be stuck. I'm going to be locked in. And really, so people want portability. That was always the promise. The promise was that the cloud was going to be some sort of utility. I would just flick a switch and change a provider, and it all magically would work. And that was the lie we were told on the early days of the cloud. Like in the UK, I can go and fill in a form and say, well, this is how much I pay for electricity now. Click a button. Or you could pay this much for electricity. I click another button, and I have a new provider. It takes about 3 or 4 days in the UK to do that whole process, right? Because electricity, it's the same stuff that comes out of the wall. I don't have to change the plugs in my house. I don't have to worry about the voltage changing. It's all completely transparent. That is true utility. Most of the services we use on cloud providers are not uniform in that way. There isn't really an open marketplace. We don't have transparency of switching, and I don't think we should want that either necessarily. I think the problem here is that we always phrase this conversation in negative terms. We talk about lock-in. We talk about lock-in, right? We say, we are stuck. We cannot go anywhere. Well, let's distill that a little bit. Really, it's not about being stuck, and I think this is the wrong way of thinking about it. You need to invert your thinking. It actually really comes down to option theory in a way. What people are worried about is it might be great now, but what if it's not great in the future? I'm going to have to move, aren't I? Oh, I'm scared about moving. That might be a lot of work in the future. The flip side to that argument, though, is to say that we're not going to take advantage of this cool product on the cloud that could give us benefit today because we might have to move later. And so by not taking advantage of that technology today, we are paying a cost today in the hope that that will avoid us paying a larger cost later. The issue is, none of you can tell the future. Well, OK, some of you might think you can tell the future, but you can't. And so that's always a risky proposition. I think it's much more rational to think in terms of different products within that cloud vendor. Some products are easier to port than others. If you think about I always like thinking about the cost of migration. You think about moving something like blob storage, so you're moving binary large object storage, that's fairly portable. The abstractions are fairly similar, as is compute, as is the ability to spin up machines. Once you've got the machines behave more or less the same. You start adding load balancers in, OK, they're pretty portable. The abstractions are the same. You start moving into the function platforms, that's an issue. If I'm running a PHP function on Azure, which I can do, I can't run that on Lambda without some kind of shim execution framework. The back end of the storage solution is even awful, even more awful. Dynamo does not exist anywhere other than on Amazon. Cosmos does not exist anywhere than on Azure. Spanner does not really exist anywhere than on Google. If you build your solutions to use those products, to move them to a new vendor, you often have to change the application code itself to make that migration. And so if you are worried about the potential migration cost, don't see it all as one size fits all. Break it down. What are the things that you would like to use? What are the things that are going to be harder for you to move? And what are the things that are going to be easier for you to move? Ultimately, the power of serverless comes from abstractions and buying into an abstraction. If you choose not to buy into that person's abstraction, you don't get the benefit of it. I think with a serverless offering, you probably should actually be all in on one platform, because there's a whole lot of issue across cross-cloud usage. Now, I think for a larger organization, it certainly makes sense to have a multi-cloud strategy. For a single solution you're building, it's rarely a good idea to be multi-cloud, purely because of latency and the fundamental challenges of distributed systems and networks, let alone the deep skill set you need to build up to be truly effective on more than one cloud vendor. There is this pay now or pay later thing you've just got to get your head around a little bit. Have the conversation, but don't necessarily believe that you can tell the future. But if you break it down into this discussion, I think it goes a lot more easily. There's one last thought about this whole area, is that people assume when you're locked in, it's always a bad thing. When you're stuck in a place, it must always be a bad thing. We talk about the walled garden effect. Oh no, I'm stuck inside the Apple walled garden. You know what? The Apple walled garden is really nice. It's like a lovely, beautiful, manicured garden. There's a babbling brook. I sit in my reclining chair, and someone brings me martinis, and I sip them by with the babbling brook, listening to the cricket, and it's a fantastic, lovely place to be. Some walled gardens are nice places to be. Don't get me wrong. Some are horrible, right? In some of them, it's nighttime. The walls are covered in barbed wire, and there are monsters behind every single tree, and you can't escape, and you want your parents. Right? I have been in developer ecosystems like that before. They're not fun, right? But some of these cloud vendors, you might well be, in your parlance, locked in. But they give you so many amazing capabilities that you might actually be better off for it. For some of the serverless offerings out there, you are starting to get some options about running now in other places with a more portable abstraction. And you can look at things like OpenFaaS, which is a platform to give you function as a service type capabilities on top of Kubernetes. That could be a good thing because there are multiple vendors that will run Kubernetes on your behalf. You could use OpenFaaS to give you portability across those things. This is getting really a load of interest right now, but it's far from the only one. We have OpenFaaS, we have Fastnetes, we have Fission, we have OpenWhisk, we have OpenLambda, and there have probably been 5 more since the end of this talk of all function as a service platforms running on Kubernetes. Guess what? By far the least interesting thing about serverless. Look at the other things, the other serverless products that we've talked about already. Things like messaging, the ability to have a portable serverless messaging solution that gives me the ability to send point-to-point or multicast. Bigger issue, much bigger ticket item, are those serverless databases, which even the main vendors are still struggling to get right. There's no portability there. This is a real, if you look at sort of the Cloud Native Computing Foundation's projects they're incubating, this is the big hole. The storage options around that stuff and the pure data plane options around that stuff are completely lacking, because guess what? That's the really, really hard problem. And so for those of you who are looking towards maybe wanting more portability across platforms and things like that, so maybe using something like OpenFaaS or one of the other 58 Kubernetes function service frameworks might be a good way to sort of balance. I get the functions, but I get the portability. But you're also going to have to potentially opt out of a lot of other cool stuff if you really want portability across those platforms. You're going to be having to run your own message brokers on Kubernetes, your own database on top of Kubernetes, and that's not necessarily an easy thing to do. So coming out of this whole thing, I'm maybe a little bit less confused in a way. I'm quite fortunate that I was around when Agile was just becoming a thing, and then out of that we had DevOps, and then we had microservices, and it's been this whole sort of slew of new buzzwords and I think it's sort of interesting. You see as transistor density doubles, right? We used to talk about clock speeds getting faster, and then we talked about there being more cores per CPU. I think the way that transistor density doubling every 18 months has now impacted the marketing world is that these terms become devalued even faster than before. I think it took a good 5 or 6 years for Agile to become meaningless, about 3 or 4 years for DevOps. Microservices was meaningful for about 6 months. I think serverless, maybe 2 to 3 months at most, I want you to get away from this idea about, I can't use it because it is serverless, I can't use it because it's not serverless. Just think about these things as better abstractions than we've had before. This, in many ways, is nothing new. I think there's a lot of people running around saying, oh, it's amazing, it's going to change the world. It's the best thing we've ever seen. It's just another iteration on our ongoing battle to create higher order abstractions to allow us to get more things done. There are no future where fewer servers. There's no future with fewer programs, with less software. We're growing the need for software way faster than we're growing the developers that can write that software. And so creating higher order abstractions that allow us to get more things done is really quite important. And so view serverless products like that. Maybe the difference is that maybe those abstractions are more tied to specific vendors than they were in the past. And that might well be cause for concern for some of you. I will say, though, if you really want to get the most out of this stuff, you probably do right now have to throw yourself all in on one of the vendors. really adopt and get to know Azure really well, really get to know Lambda really well, really get to know Google really well, if that's where you choose to spend your time and energy. That's where you're going to take the most benefit, the most advantage of these sorts of things. The benefits in terms of reducing that undifferentiated heavy lifting are quite large. And certainly of all the new abstractions I've seen over the last 20 years in the industry, this is a big step change. This is as big a step change potentially for application developers as it was for operations people when the public cloud became apparent. I think that's sort of the order of magnitude, just that we now get to feel a bit more of it. I think it's also just about experience. We're getting smarter at understanding what we want. A few words of warning, though. The ideas behind this stuff are conceptually quite simple. I still think the execution is really very poor. When you look at, say, how the details of how you get Lambda working, it's still nowhere near as neat as the idea is. And most of the database options are also incredibly poor in terms of how easy and turnkey they are. Go and spend some time with the calculator that Microsoft provides for working out your allocation units for your Cosmos usage, and then come back to me and tell me, oh, it's easy. I don't have to manage around use. It just scales up and scales down magically. So I do think we can and should do better. But just remember, it's abstractions all the way down, and that's absolutely fine. I have just done a whole video series on serverless and how serverless and microservices are related. You can go watch that on Safari, which is O'Reilly's platform. You can watch that for free while your builds are on. And I'll be sending out the slides for this talk and everything else on Twitter afterwards. And if you want to know more information, you can find that over at my website. But thank you very much for your time. Time for questions?
I have a few questions on an app. Please remember to rate the talk, and you can ask questions on the app.
Is there an app?
Yes.
What's wrong with paper?
You can actually ask with the mic in the middle, or send paper notes. That works.
Well, Pinny, if you ask questions via the app, Pinny will strip out all the questions I don't want to answer.
Yeah. The first one, yes. Can you give some advice? What strategies to use to migrate from monolithic systems to serverless?
So I'm a consultant, so what answer do you think I'm going to give? It depends. Of course, I'll charge you a lot of money to say that. It all depends. I mean, first, it does depend. So firstly, are you on the cloud? If you're on the cloud, then great. Then I'd start looking at, actually what I'd start doing, this is the way I've driven this with a few teams, is get all of your developers to list out all the things that they do that aren't about actually writing code, and identify where they spend that time and that energy. For some of the clients I've worked with, some of the biggest wins have been just switching from using a traditional database over to using something like Dynamo or Cosmos. For other clients, it's actually been piecemeal building new functionality on cloud functions. But I would drive this by looking for the win, right? So think about the work and the effort you do. Everyone's application is a bit different, and so it's harder to say exactly you should definitely do this and then this. And so for you, it might be not having to run your own RabbitMQ cluster and using SNS on Amazon, for example. But I would list out what are your developers' pain points and then see what serverless functions on your, or features on your cloud could address that. I hope that was good. Yep. I don't know who asked that.
Hey, Sam, thank you for your presentation. So while in microservices, the most fundamental thing was actually sociological one. So basically, you have different teams who are like distributed across the world. They are like working on different parts of the system. So here you're saying about billing. Isn't just it easier to charge for the CPU and memory usage?
It's sort of. Oh, that's a good question. Damn it. Right. I think for me, the billing isn't necessarily new. It's a continuation of those ideas that we have coming out anyway. And I think being charged for what we use is the interesting part here. And so I think this is the thing, it's easier. I think you had the right question. When we first had the cloud, and it was like, oh, we can spin machines up, we can spin machines down, we're going to be charged for what we use. And then your traditional operations department would go, or your typical accounting department would go, that's too confusing. We need to know a year in advance how much money we're going to spend, because they were used to buying machines as a capital expenditure thing and writing it down against the accounts. And when you started moving to per-month billing with variable billing cycles, that was really disruptive. And I think we're seeing a continuation of that with serverless, because you're right, it's easier, it's consistent. And it took a while for us to realize, yes, it can be consistent. It's also way higher. And so if you get better at that and you start thinking about those per month billing cycles, and then I think it's an iteration. I think it will take time for you to get to that next level. It will happen, but it's not going to be easy as you go, if that makes sense.
Yeah, but even with containers, you can just calculate the amount of the CPU usage. If it's not being used, then there is no usage, so you're not charging for that.
Well, only if you turn it off. And that's the thing, you have to turn it off. That's which is the missing part. Simon Wardley says, serverless is less DevOps, more fintech. Arguing that there's going to be whole new tribes that will appear inside organizations whose job it is to handle cost accounting for the use of serverless cloud products. This may well create a whole new discipline in terms of IT accounting. I hope I don't have to give that talk in 12 months from now, though. Thank you. Oh, we'll do one more here, and then we'll switch.
Let's say I want to take advantage of serverless benefits like fine-grained scaling and adapt to the workload. How would you make it work for data-intensive, low-latency apps? Is it possible? And if not, what is
so low latency is interesting because some of the issue with any cloud services suffer from can suffer from variable performance. And a lot of the time, your variable performance is due to what else is happening on the cloud. There was some really great stuff done by Jan, who I think is here somewhere, the Burning Monk online, looking at variable performance of serverless functions at time. John Chapin did some work looking at variable performance over time, where you would see functions would be behaving differently at different times of day, and it wasn't necessarily something you could plan for. And so you'd often have to give your functions more memory than required to get guaranteed throughput. And so when you start getting into low latency, what you're often talking about is consistent behavior, consistent throughput and performance. And so if you're concerned about that, what I would say is your only thing you can do is actually build the solution or build a sketch of the solution and see it out, see what variability you get. And so for me, it's less about the serverless products necessarily. It's more about the fact that you don't have that control and you might be a bit more vulnerable to sort of the cloud weather effects. But certainly in my video series, I go through this. But if you look for stuff done, so if you were to search for the Burning Monk and function performance, or the work done by John Chapin over Fibonacci calculations, what he found was that he ran a Fibonacci calculator on Lambda, and he would see, with the lower memory footprint sizes, he would see incredibly variable performance of that over time. If he whacked up the memory to 1.5 gig or something for the process, he would see completely consistent performance. And so you guess that under the hood, when you're giving these functions smaller memory, what's actually happening is they're using burst capacity when those machines are underutilized and therefore going faster than you'd expect. The Google Site Reliability engineers sort of have a mantra, which is it's better to be consistently slow than inconsistently fast, because you can plan with things that are inconsistently slow. So that would be the data-intensive stuff does not worry me in that question. It's the latency issue.
The last question?
Yeah. One more question. So, the serverless functions, we already seen it somewhere. So basically, we have request response context, which is called PHP, for example. And it's, there it goes not very well when you're in a particular context. Do you see that there are going to be some issues with that as well?
Oh yeah, there were lots of other sort of challenges, certainly around function invocation. So some of the other issues which I think are legitimate are the developer workflow. How do I debug these functions? The story from Lambda, for example, is quite poor. Azure is head and shoulders above in terms of giving you the ability to debug locally and debug on the cloud, whereas Lambda has more of just a local emulation model, which is not the same thing. I think that will get better. I hope it will get better. But at the moment, that's why part of the reason why I think Microsoft are ahead on the cloud functions game. One of the other issues is monitoring. And again, Jan's been doing some great work looking at how you actually understand and troubleshoot things that are happening in a serverless system. You should also look at the work being done by charity majors, looking at how you get sampling and tracing out of those systems. Things like app dynamics on Azure can help, and CloudTrail, but they're not the whole thing. So those are the two big ticket items that I see as being an issue that people are hitting. And I think over time, as we go from companies that have been having these solutions for, there are 0 to 1 year problems, and then there are 1 to 5 year problems. I think we're starting to see the 1 to 5 year problems coming up now, and we're seeing solutions coming out to solve them. But those are the big two, troubleshooting and the other one I said. Whatever I said. Troubleshooting and something else, anyway. All right, thank you so much for your time. The slides will be out on Twitter, so thank you very much for your attention and the questions.
Thank you.